Hello guys, welcome to my YouTube channel Matlab and RT Lab. So as you can see, the topic of this video is modeling of solar PV system with the help of equations in Matlab Simulink. Okay, let me clear first. This video is only like a basic type video. Who are new in Matlab Simulink. Okay, this video is only for them. So what I'll will see here today, how to make one simple PV system with the help of equations. If you read papers, then you'll see like in the modeling section there will be like equations given for the modeling of the PV system. Okay, so by using those equations we'll build this model. So okay, I'll show you all the equations and all. Let me just see first. Look, there is irradiance input I have used. Okay, depends means depending on the equations, it could be like maybe you can use voltage also as input, but I think there is not many equations available that voltage input support. I don't have that much idea, but look, here we have used only one input. Look here, this one step signal I have used. This one only basic. Okay, this model you can improve by yourself. Okay, just to get an idea how to design just PV system with the help of equations, you can watch this video. Look here, I have used one step signal. Okay, step signal you can vary as means your requirement. You can put the value, you can change the value of equation. Suppose you need to change how the output it is coming, you can check in the by using one scope here I have used here. Okay, just simply if you search step, it will come. Okay, on the screen double click here and just search anything, any library block or anything, it will come. Okay, and after that input, inside this PV written, PV1 written, inside this there is there the equations are there. Okay, after that here one boost converter. Okay, you can say it is boost converter type. Okay, and yeah, after that only the whatever I and V is coming here, output it will show. I have already run this model. Upside here current value, downside here voltage value, and this one is the power. Okay, so here is one resistance, one inductance, one capacitor is used. Let's see the values. Okay, capacitor value, resistance. I'm not telling you to put exact values and means whatever it is you are seeing here, you need to improve the model. Okay, if you want to design one PV system. Okay, I'm just giving you just simple idea only. There is one voltage measurement. Okay, sorry, and here is one current measurement, here also one current measurement block. Okay, and nothing else. Yeah, let's go then inside this PV model, what's in there. Okay, inside PV model you see, look, this one input irradiance coming from that step signal, and this one is a Matlab function. You can see a Matlab function. Okay, Matlab function, you can just double click on the screen, Matlab function, it will automatically come. Means not automatically, you have to search and it will come. Okay, same thing. just don't get confused. Like here, the one MATLAB function I just took now, it's only one input and one output. It will depend on your equation. Okay, let's go inside this MATLAB function. There is sample equation. Look here, function only one input and one output is there, so that's why you are getting that's only one input u and only one output y. Okay, so don't get confused, it depends on your equation. Let me delete this. Okay, and here is one. From here we are giving two input v and irradiance, and from that we are getting IPV. Okay, so from that we are getting IPV. So our main aim from this MATLAB function is to get the I of PV system. Okay, after that it will go through one control current source. Okay, so this will give you the two port, one positive and one negative port, so that you can connect boost converter, or means you can connect the PV system with any circuit or anything else. Okay, it is giving one one positive and one negative side by using one controlled current source with the current output signal. Okay, after that there is one voltage measurement, because I need the voltage as an input. I am taking the voltage from this control current source. Okay, and I'm sending this to that MATLAB function. Okay, where the equations are, by using one memory block. Okay, memory block or delay block you can use. Okay, you should use one at least memory block or delay block when any feedback connection you are making in the like loop type. It will be going like loop type, na. So for that you need one delay block or memory block. So let's go inside this MATLAB function. So here's the equation. Okay, look here. I think, is it visible or not? Maybe visible. Our last equation, look here, our main equation is IPV is equal to NP into IPH minus, like so many things. You will find this equation in the paper or something here, from means for making the model. At least you are following something, na? So you will find it there. So our main equation is to find the IPV, calculate the IPV. Okay, so we are putting that equation here, and these things are like a normal thing, just putting simply by using keyboard. You have to type all these things. Okay, at first look, function IPV, we are going to calculate the IPV, and where two inputs, one is irradiation S and VPV, voltage of the model. Okay, so here IPV equation, in IPV equation there is like IPH also there, and G also there, and V also there. Okay, these are the thing you will find in your means equation. This video is only at first I have told, like by using the equation how to design, how to model a PV system. Okay, so these are the equation you will find there, and just the values of those I have given: Q, K, A, T, T, R, K, T. You just normally need to type all these things, and nothing that much difficult thing. Okay, I'm not telling you to put these values same as it is here. You must have to follow whatever paper or anything you are following. Okay, so this is just simple, like you just all the variables value you have to put. Okay, by depending on these values it will give the output. Okay, if you have any confusion you can comment in comment box. I'm just not going that much details here. Means for going details here, we need one paper here inside, so that I can explain nicely. Okay, look, can you see it? Maybe now you can see it properly. Is there any way to zoom? I don't know. What is think? There is one input and one two output. IPV is the current of the PV system output, and for the for calculating I, we need V of the model and S irradiation. Okay, we didn't give temperature as variable, means we didn't vary the temperature according to weather condition. Means this model is not comfortable with the real time. Okay, real condition. Fixed temperature here is given 290 and at 300. You have to change obviously all those things. You have to, at least you need S means irradiation and temperature as the input, and output will be I and VVB. Okay, maybe you will find that type of equations in many paper. So this is like simple thing. Okay, after doing that, automatically VPV and S, these two option will come in the input as a input. Okay, outside of this Matlab function, and IPV will come as a output from the Matlab function. So by using here again one control current source, we are getting one positive and one negative part, so that we can able to connect this system with any circuit. Okay, we need the VPV as a input to the equations for calculating the IPV. So we are using one voltage measurement after this control current source, and by using one memory block, memory or delay block you must use when there is something loop going on. Okay, in any calculation in Simulink, if there is any loop, at least you need to add memory or delay block, something you have to add, otherwise you will not get the proper result. Okay, so let me run once. We'll run one. Oh, this one is power guy. Okay, I think you know. Here sample time is given 2e minus 06. Okay, simulation type discrete. According to your requirement, you can change. You can make it continuous also. Okay, so let's run. You can see the like values here. Okay, power output. Again, I am telling you guys, this video is not a like final model type. You can use this model directly in your project or anything, just for giving an idea how you can use the blocks, how you can use the equations. Okay, this is a basic idea only. So let's check the output. Is look not that much good. It's taking so much time to get settled. Okay, 0.1 second it is taking to get settled, and after that we are getting a constant value. So you can use one more thing, means for this, for decreasing the settling time of this graph, you can use PID controller. Okay, PID or PI controller, and in like by using PID control from the, look here, PID controller you can use with the boost converter. Okay, and you can auto tune automatically. There is auto tune, tuning option is there. Look, you can auto tune. You have to just put this continuous and all, whatever it is according to your model, After that, this P and I value, it will automatically come by tuning it. Okay, this work means you can do the auto tuning here. You don't even need to calculate the P and I values. Hmm? So means after using this PID controller, you can fix the settling time. Okay, this settling time at least, yeah, you can. I don't know how much you can able to settle, means how much the time duration you can decrease compared to now whatever it is taking. But yeah, you can use PID controller, and surely it will help you to decrease the settling time. Okay, and make the to make the output also better. Let me delete it. So that's it, guys. If you have any like doubts, if you have yeah, any doubts about this basic model, you can ask me in the comment box. As soon as possible, I'll reply you. Okay, so thank you for watching, and don't forget to subscribe this channel, because I am going to upload this type of videos, Matlab and RTLab related videos, and basic videos. Obviously, basic videos I used to upload, and I will be uploading in future also. So subscribe and get notification when I will upload, and connected with me. Thank you. Bye bye.